Hi everyone. If you watched my last video on leveraging open source to make a web scraper, you would have seen me talking about how I used PocketBase and Notify to make a web scraper that sent me push notifications when it found anything interesting on the internet. Now, I already had that put together and complete when I recorded the video, so I didn't go into the code in too granular of detail. But I thought it would be useful to implement it on video so that anyone who is interested in learning how to build something like this can follow along with my programming of it and be able to write up the code themselves as well. First, what you want to do is visit the PocketBase GitHub. I'll put the link in the description, but it's github.com/pocketbase/pocketbase, and you can access their download. Hit link. Somewhere you can access their download link, probably through the docs. It's right there. So access their download link for your appropriate platform. This is where you can get a PocketBase binary and you can get a nice interface for interacting with the database. We're not going to use this just yet, but this will be handy to have. Next, what I'm going to do is I'm going to go into an empty directory. Go ahead and make an empty directory for yourself. You can see, let's go ahead and remove any layover files here. And we're going to open up a new VS Code session. Inside VS Code, we're going to go ahead and make a new file, main.py, and it's empty right now. So first, the characteristic aspect of a web scraper is something that makes requests. In Python, the recommended package for making web requests is the request library. So let's go ahead and import requests. Now that we've imported requests, let's do an example to demonstrate to ourselves that we know how to requests work. Let's go ahead and print out the response of this request here. And we can see a response of 200, so everything's working just fine. We can also print out the text of the request, but it's just a raw HTML string. What we want to do is, once we get this HTML string, is we want to extract all URLs that are available within it. So what we're going to do is use something called regular expressions. Python has a built-in regular expression library called re. If you're not familiar with regular expressions, I highly recommend you read up about the topic because it's a great tool to have in your programmer's toolbox. Let's get a regular expression that allows us to find URLs inside a large string of text. Fortunately, I've already pulled something up from Geeks for Geeks. You can see that they have a long regular expression string right here that extracts URLs from some body of text. So let's go ahead and make this our URL regex. And that's interesting. It already has something for us, but I'm going to go ahead and replace it with what's on Geeks for Geeks. Just cleaning up the string a little bit. Excellent. Now let's test this. We're going to print out the results of finding everything in our URL regex for some example list of URLs. You can see down there in the code output at the bottom that we did accurately get 3 Google URLs in 3 separate capture groups. So I'm going to clean up the code a little bit here. Running it again. We want to make sure that we only get the URLs that we're interested in. You see, we're still looking at a list of tuples of capture groups, but we only want the first element there. So let's go ahead and say found equals the following. And you can see that we've extracted just the URL successfully from this body. Now let's go ahead and try and find all of the URLs that are available on a website, such as this should rather be content because it's not necessarily directly a list of URLs, and we'll see this here. Let's look for all the URLs available on github.com. So we're going to go ahead and get the body of the web page at github.com by doing request.git. So this will get the text of the web page when we visit github.com. And you can see that we've extracted a broad list of URLs. Very long here, but you can see that we got a lot of very useful things. A lot of them are GitHub assets, but what can you do? Now let's compartmentalize what we're doing here into a function. We don't want to just get URLs from github.com. We want to get URLs from any arbitrary website, right? So let's break this out into a function. Get links on page, and this will be the URL. And we want to return our found URLs. And let's go ahead and test this out to make sure that it's still working, and it looks like it is. Excellent. So we've already broken out one core function to get all the links on a given URL and return that back to the programmer. So let us leverage this a bit further to get all the links that are in a set of pages. So this will get the links on all the pages provided by some URL list. This is not necessary here. Actually, was that necessary? Yes, it was. This is fantastic. It did actually auto-make it for me. That is an accurate implementation. So this will get the links on a list of pages. This may or may not be useful. We'll see going forward. So what do we want to do now? Let us think. We have a way to get the URLs off of a website. Now we want to store the URLs, and we also want to visit the URLs again. What I'm going to use is the Python multiprocessing library to create a few workers to make this work easier for us. The Python multiprocessing library lets you run separate Python processes that communicate through a predefined set of communication constructs, such as queues, to pass information to each other and allow workers to do work, pass it to other workers, so on and so forth. So what we're interested in creating is a worker that feeds in these URLs and a worker that consumes these URLs and spits out the URLs that it finds on the page. And then it'll be easier to just implement, and then we can talk about it while it's being implemented. So you can see that in general, in multiprocessing, we'll start a process, so let's go ahead and import that. And a process will accept some function to do its work. So let's say def get, let's see, populate URL queue. And this is a worker. Actually, yeah, let's have some seed URLs. So this is looking good, this is looking good. We're also going to want a queue construct. Excellent. And this will be the queue type. So we're going to have some URLs passed in. We're going to go over the URLs and we're going to go ahead and drop them in the queue. The reason that we're passing in the URLs in this way is eventually we want to expand the list of URLs that we have, and we want to continue to iteratively visit URLs that the workers are finding, pass them back into the queue, so on and so forth. But right now, we're going to skip over that and just go off of the seed URLs and populate the queue. Now, let's make a worker to actually visit the web pages and get the URLs from the web pages. So, getting the URL from the web pages, we'll start an infinite loop where we continually pull things off of the queue, get the links from the URL, get the links off of the page, and right now the code has automatically put them back into the queue, but we may not necessarily want to do that. I want to have two separate constructs, one where we drop our found URLs, and one where we pass them back into the queue, because it's possible that we want to do some pruning in the future, so we don't want to just naively drop them back into the queue. So you can see that we would pass back our found URLs into some found URLs queue, rather than just directly putting them straight back into the URL queue. This will let us prune our results later on. So let's go ahead and make a process to drop URLs inside the queue. Actually, we don't need to import anything. We'll just say excellent. And we need URL queue. And what are some web pages that we'd be interested in? Google.com is a good one, but it would lead us to some weird places. Let's take a look at Hacker News. This leads us to a wide variety of different sources, and it would be a fantastic place to start our searching journey. Excellent. We have our URL queue. We have our seed URLs. Now let's define a visiting worker. And we want a found URL queue. Everything's looking great. Now we need to start our workers. These first two commands will start the workers doing their job, and this join command will wait for the visiting worker to finish its work. But since it never actually finishes its work, this basically just means let the Python program run forever. Let's also print out the links that we find as we find them. And let's run this code to see how it's doing right now. Look at that. We found a lot of links, all on the base Hacker News page. But now we can see that the process effectively terminates because we have found all of the links available on the web page at that point in time. We visited them, but we don't know what to do. The queue is empty. So let's start getting to work on repopulating the queue. So this will look through the found URLs and drop it in the queue on some condition. So, why am I doing this filtering? Well, some URLs get quite long because you might recursively start visiting web pages that just end up being assets, right? We can see this from earlier on when we were seeing githubassets.com/images/ a lot of stuff. So we're going to do some early pruning by just saying if png is in the URL, return false. This should clean up a lot of our static image finding things and only have us visiting web pages. This should be beneficial, but we'll actually see how beneficial it is in the end. So let's go ahead and make a worker for repopulating. Excellent. So we should see an infinite loop getting started here because, let us start the repopulating worker. Now, how are we getting an infinite loop here? The queue worker fills up the queue initially. The visiting workers will visit the URLs and drop it in the found URLs queue. And then the repopulating worker will move things from the found URLs queue back into the main URL queue. You can see that we got some sort of exception here because a schema was not provided for a URL that was discovered. We don't want that. Let's cancel and see what's going on over here. It's definitely preferable that we have the schema, but what we're going to go ahead and do is we'll prune over here on get links on page if the page is not valid, right? So we want to say this is a odd function here. What we want to do is say if that and this will basically do some free pruning for us if we don't have URLs that look like how we want them. And now, look at this. We have an infinite loop. We're finding links, getting links on pages, and we're we're dropping them in our queue. But this isn't very useful so far, because what are we looking at? All of this information is just getting printed out to the console, and we don't get to store it or look at it. And this is where PocketBase comes in. So I'm going to go ahead and snag a PocketBase binary that I have nearby. So I'm just moving that into the web scraper directory that we're working in. And I'm going to start up PocketBase. What I'm doing here is I'm just making an account using my email and setting a password. This is all being run locally, so these login credentials are being hosted, stored locally on my machine. But now what I have is a PocketBase instance. We see that we have no collections, but this is where all of the URLs will go. So let's go ahead and create a new collection. If you want to follow along, be sure to visit the PocketBase page, go to the documentation, like we described before, and download your appropriate client version. Let's create a new collection. We'll call this sites. Sites. And we should go ahead and have a field called URL. And let's also have a field called visit time. Actually, let's not have this second visit time field. It's not that useful because we should automatically get a created time field which will be enough for us. So we'll create this table. It has ID, URL, and you can see created and updated. Excellent. So how are we going to interact with PocketBase? Well, we could use the API as talked about here in the auto-generated documentation that's locally hosted, but you can see that there is no Python client. It only provides JavaScript and Dart. So what we're going to have to do is hop over here and go to PocketBase Python client and get this PocketBase Python SDK. This is a third-party SDK that is fantastically made and will allow us to use PocketBase from Python. So I have successfully just installed the PocketBase Python library, and let's go ahead and pull that in. Looks like it has been pulled in successfully, despite VS Code not saying it has. Just need to refresh, and it looks like everything is good. So we're going to go ahead and create a client. Make sure to target the appropriate port, 8090. Excellent. So we've created a PocketBase client, and I'm going to make sure that my permissions are set up appropriately by visiting the site, going to the API rules, and we're going to go ahead and unlock all these actions. We don't want only admin users to be able to touch all this stuff. We'll want anyone to touch it. So let's hop over here. So now we have a PocketBase client. If we've found a URL, found URLs, and we have a queue repopulation worker, right? But what we also want to do here in the queue repopulation worker is we want to record this to the database. So somewhere over here, we want to store the URL inside of the database. So when we put it back into the URL queues, after we've determined that the URL is valid, we want to store it. So we're going to go ahead and say client.records.create. And we're going to go ahead and put down the URL, but let's see if that is the correct way of doing it. Looks like we need to create, pass the database name, and then pass the necessary data. The database will be sites, and we will pass the URL, a dictionary containing key URL and the URL itself. Let's go ahead and run this to see if everything's good. When we refresh this, looks like something's not working. PocketBase object is not callable. There are clients.records.create rather than client. Let's try this again. Things seem to be flowing nicely. We'll refresh, and look at that. We have ingested the URLs that we are finding into PocketBase, and we can see the created and updated time for each of them. Fantastic. We've already downloaded over 4,000 URLs. So let's cancel this, refresh the page, and see what we're looking at. We have over 4,000 URLs that have been successfully web scraped from Hacker News and stored in a database. Now what do we want to do? We want to submit these things for analysis, right? We want to find interesting URLs. These URLs aren't particularly interesting, right? I'd be interested in the content of the URLs. I want to see any URL that has wolf on it, since my name is Thorn Wolfenbarger. So let's go over here and create a analysis worker. So the analysis queue I am expecting to contain the URL that it is coming from and the content of the URL as well. So we would unpack that by saying URL and content equals get from the queue and we want to look for the word wolf, right? So let's say we're going to create a record and pass the content in. So where will this analysis queue get populated? Well, when we visit a URL and getting all the links on a page, we're going to see where this is used. Actually, where this is used, not quite there. Finally, over here, get URLs from page worker. We put them in the found URLs, but we also want to drop them in the analysis queue. So let's add an argument here. Excellent. Let's make sure to create and pass an analysis queue. And then let's create an analysis worker. Excellent. So now we have a new worker that will analyze the URLs and store them in some table called interesting content with URL and content. Let's make that table. So if wolf is in the content, we're going to go ahead and drop it in the interesting content queue with the URL and content. Let's go ahead and clean up our print statements. We don't care about that. We don't care about that. But we would be interested if interesting content shows up. Let's run. Yes, we need to make sure that we pass the appropriate things to the queue. So over here, when we get the URLs from the page, notice how I just put the link in the queue? Well, I'm actually expecting to see the URL and the link, like I mentioned earlier. So now we do that. We make the fix, run the code again. And why are we not finding anything interesting? Because I actually need to pass the content here, not the link. So right here, I'm getting the links on the page. But I actually also want to get the content from the page. So let's rename this function, get links and content. To do, pass in content here. And let's modify this function slightly. We have the found URLs, but we also want to pass the content. Let's run it again. Let's first cancel it, now let's run it again. Something isn't looking good. Looks like we're getting some permission errors on finding interesting content. because I need to come over here to the settings and unlock this as well. Just do some debugging. Some fast debugging shows that that is working. And let's wait for interesting content to flow in. Ooh, we're finding Wolf a lot. Somewhere on this page, the word wolf exists. I cannot find it, despite it saying that it exists. But it looks like we're visiting the same URLs over and over again, and that's not very good. So what we should do is I'm going to go ahead and delete only have how many records do we have? Yeah, let's go ahead and manually delete this content. So how are we going to address the fact that we're feeding in the same URLs over and over again? Well, we probably want to keep track of what we've seen before. So let us come over here and see our populate URL queue worker. Now we want actually, that's not it. On the queue repopulate worker, our scene URLs will create a sec. Whenever we get a URL, we say if URL in scene URLs will continue, because that means we've already seen it. If we haven't seen it, we'll add it, and then we'll move on. So hopefully this prevents our issue for visiting the same URLs over and over again. Not quite. Submitting too many times to the analysis queue. Because we want to submit the URL, not the links that will follow from the URL. So let's back out, run this yet again. And excellent. We only found wolf one time so far. But you can see that we're still getting a lot of distinct websites. 24,000 about to be exact. But unfortunately, none of them are containing wolf. But that's okay. Let's change wolf to something more common. Let's say web run it again. And look at that. Now we're getting a steady stream of finding things that have web in them. We'll cancel this for a moment. Refresh. And we see a lot of cool things. Interesting. Well, maybe I'll keep that in my back pocket. So we are gathering websites and we are filling in the interesting content. But we don't want to stand at our computer all the time. So let's open up Notify. Notify makes it easy to send a push request and get information from this post request on your phone. So download the Notify app. I'll skip over that. It's very easy to set up. And we'll use the web app instead here. So we have the web app. We'd be interested in some new topic. Let's say interesting URLs. Now, if anything gets sent to this URL, we'll be notified over here. So instead of printing out found web and content, we're going to make a request. Make sure to pass an appropriate schema. And look at that. Everything is just flowing in. Changing this to JSON, so hopefully we get a slightly better format. And there we go. Look at that. So now we are getting push notifications to our desktop or potentially to an app if we are interested for every single web page that has the word web on it. Now, I know that this took a while, and I know that I had a few things that I got hung up on, but I hope walking through this one by one, all the individual steps in making web scraper like this, has given you the ability to go out and make something like this on your own. Potential extensions for this project could be making the web request faster by using multiple processes rather than just one process for the web visitor. Other extensions could be analyzing the URLs for sentiment and only sending these push notifications if the content on the URL has a particularly high sentiment score. There are tons of extensions that can be done, and I'm looking forward to what you might build using these two open source tools, Pocketbase and Notify.